Watch the complete playlist on the app Pions. Download the app now.
Wire has a resistance of 16 ohms. So let's write R, that is equals to 16 ohms. It is melted and drawn into a wire of half of its length. So let's say the length when this was R was rho L by A. L was the length and area is A. So if it is melted and drawn into a new of half of its length, let me first draw our initial. Roughly speaking, it looks like this, with the length of this wire as L and area of cross section was A. Now we are melting it and making it into half of its original length. So half means it will look like somewhat this. So as you can see, now the area of cross section increased. Let's call it as A dash, and the length became L by 2. Clear? So melted and drawn into a wire of half of its length. Calculate the resistance of the new wire and what is the percentage change in its resistance. So we have to find two things. One is percentage change and one is new resistance. Correct? So to figure out the new resistance, okay, our new resistance before we find, let's figure out what is our A dash. So as we know that when it is melted and recasted into a new wire, its volume will not change. So volume of the previous wire will be equals to the volume of the new wire. And what's the volume of the previous wire? Sir, area into length of the previous one. And that must be equals to the new area into the new length. That is L by 2. Correct? So L and L cancels both the sides. 2 times area, that will be equals to the new area. As you can see, the mathematically it is saying that the new area will become double of the previous area, and that is obvious that when you are decreasing the length, the area gets increased, and when you are increasing the length, the area gets decreased, and that is you can see from this expression also. Now we got our new area. So what will be our new resistance? Sir, our new resistance will be R dash, and that will be rho. Rho will not change. Why? Because it depends only on the material and the temperature. So here nothing is changing. So rho, length L, L will become L by 2 and new area will become A dash. Correct? So what is our rho L upon 2? This 2 I am writing here. And what is our A dash? Sir, A dash is twice of A. Correct? So this will become 1/4 of rho L by A. Now what is rho L by A? Look here, it is 16 ohm. Rho L by A is 16 ohm. So this will be 16 upon 4, that is 4 ohm. So what is our previous resistance of this wire? 16 ohms. What is our new resistance of this wire? 4 ohms. If this is our previous resistance and this is our new resistance, what is our change in resistance? Change in resistance is delta R, that is previous one and new one. Okay, previous one minus new one. 1 second. So previous one minus the new one, or we can say the larger value minus the smaller value. Okay, not necessarily always previous and new. So we will always subtract higher value to lower so that we can keep the percentages in positive value. Okay. So change in resistance is simply 16 minus 4. 16 minus 4 is 12. Clear? And what is our percentage change? Now this we have learnt in class 6th or 7th standard, that percentage change of anything is change in that value upon the original value into 100. No matter resistance, even if they ask you anything, percentage change of anything, okay, then change in that anything upon original anything into 100. That's our percentage. Okay, this is there in 7th standard. So if you have any confusion, you can go through that once again from 7th standard or 8th standard book. Okay, delta R here in this particular problem is 12. R here is nothing but 16 into 100. Let's cancel out 4 4s are 4 25s and 4 3s. So how much percentage change? 75% change in resistance. I hope this is clear.